welcome to your last geometry recording of semester 1. That's right, this is going to be the last recording that you guys are required to watch in semester 1. That's exciting. We are in week 17. This is the week of December 13th. And this week is going to take you through all the way to the end of the semester, since there aren't, the end of the semester ends on a Wednesday instead of starting a new week. I'm just going to make this week go all the way through to the end of the semester. So you will know what you need to finish, what assignments, and once you are done with those, you are done for the semester. Woohoo! That is exciting. So we're going to start with a warm-up that goes back to some stuff we learned last week, where we've got a triangle with an angle bisector drawn in and some labeled side lengths. And what you need to do for the warm-up is use those labeled side lengths and what you learned about how you can set up a proportion last week to solve for z. Once you solve for z, then you can find the length of BC and ZD. So your first task is to set up a proportion that allows you to solve for z. Solve for z. Once you've got z, you can plug that value in and find BC and CD. So I'm going to have you do this in your math notebook on your own. When doing this on your own is going to get, you're going to get more out of it, and then you can check your work with mine. So go ahead and click pause now. All right, so what did you guys learn last week that's going to help you solve this warm-up problem? You learned the triangle bisector theorem. The triangle angle, I'm missing angle in there, the triangle angle bisector theorem. And what is that theorem? Well, when we've got a triangle and we draw in a bisector, an angle bisector. So remember, an angle bisector cuts the angle into two congruent parts. So this might not be perfect. I think that angle bisector needs to go a little bit to the side. Let's just get rid of that. Put in a new one, so more of an angled bisector. There we go. So we know that these two angles are congruent. They're marked as such. So we know that this segment is an angle bisector because there's one arc here and one arc here that lets us know that those two angles are in fact congruent. Let's go ahead and label this triangle. So we're going to say this is vertex A, B, C, and D. And now, because I know that this angle here is congruent to the other angle next to it, this angle here is congruent to this angle here, I can set up some proportions now. So I can say that this side length down here, the bottom, BD, put that over the other side length down at the bottom, so BD and DC, and set those equal to, go back to this side of the triangle, and we're going to say this side AB over this side AC. So what I did there is set up a proportion. Again, I'm taking this side length at the bottom of the triangle, the base side, setting it over this base side, and then setting it equal to, going back to the triangle on the right, AB over AC. So we can use that to help us with this triangle. So we're going to say side BC, we're going to put that, which is Z minus 4, all over the other base length, which is just Z over 2. Set that equal to this side length here, which is 12, over this side length, which is 10. So now we've got a proportion. And to solve for proportions, we know that we can cross multiply. So I'm going to take 10 times Z minus 4, set that equal to, when I cross multiply the other side. So that's Z over 2 times 12. So let's clean that up. Let's distribute on the right side. So I would have to distribute that 10 times z, so I would have 10z, and then 10 times -4, which is -40. Set it equal to 12z over 2. So if we multiply 12 times z, and then we would divide it by 2, we get 6z's. So set that equal to 6z. And now we just need to get all of our z's on one side of the equation. So I'm going to subtract the 10z so that we get all of our z's on one side and all of our constants on the other side. So what do we have? I'm going to come back up. I'm going to move my answer up over here. Running out of space. So 10z minus 10z is 0. We're left with -40 equals 6z minus 10z is we're left with -4z. What's my last step in solving for z? Divide each side by -4. And what do I get? What does z equal? What's negative? So the -4 cancels out. -40 divided by -4 is 10. So z would equal 10. Z would equal 10. Now I'm not quite done yet. I'm not quite done. Now I need to go in and plug in that value of negative, or I'm sorry, not negative, it was positive 10 for z. For both of our z's, we know that 10 is z. So 10 minus 4 to give us, I'm going to go in a different color. Write it up here. So BC is going to equal z minus 4, which is 10 minus 4. So BC is going to equal 6. And then the length of CD is going to equal 10 divided by z over 2. 10 divided by 2 is 5. So there's our two answers. So first we had to solve for z, then we use z to find the length of BC and CD. And we're done. That's it for the warm-up problem. So if you need more time to take down and complete your notes, if you made a mistake and you needed to fix it, go ahead and click pause. I'm going to move on to the next slide. All right, so this week is the not really the last, it's the last of, I should say, new assignments. Add that in there. So again, because I'm going to make week 17 take you all the way out until the end of the semester, this is the last week of new assignments. So in week 17 folder, you're going to be completing Unit 5, not Unit 5, that's next semester, Unit 4, Session 5, and Unit 4, Session 6, where you're going to be setting up more proportions and solving for unknowns and triangles. And then you're going to take the Unit 4 test, and that's the last test in the semester. Woohoo! And then we're going to wrap up semester 1 with a little portfolio assignment, where you guys were going to take some time and look through all the assignments that you've completed and find some that you're most proud of and tell me why. And that's it. That's all the material you're going to learn and complete in semester 1. So the last day for submitting work is December 19th, and that's Monday. So that's the last day for submitting late work and redos. I've messaged you guys about this, but I wanted to remind you again. I'm going to go on to the next slide. More date stuff. The last day of the semester is December 21st. But the most important thing is that the last day for redoing assignments and submitting those, and then submission of late work, is Monday, December 19th. And then just remember that you do need to send me a message when you submit any late work or redos to get those graded. So make sure you're doing that. Moving on. So what are we learning about in Unit 4, Session 5? So we are learning about proportional perimeters and areas theorem. So we're looking at perimeters and areas. So if the similarity ratio of two similar figures, so if we've got two similar figures and the ratio comparing those two similar figures is figure A over figure B, or just A over B, then the ratio of their perimeters is just going to be the perimeter of A over perimeter of B. And the ratio of their areas, though, is if you take A squared over B squared. So you're gonna square those ratios, and that's going to tell you the ratio of their areas. And we're going to put that to use, so you'll see that in a moment. And then we've got some similarity ratios where we can compare our perimeter and our areas. So similarity ratios are just when we compare corresponding sides. So if we compared side AB, we would compare it to the corresponding side DE, and that's that ratio right here. And we could keep going. You guys know what corresponding sides are. Corresponding sides are, they're sides on two different figures. So corresponding means on two different figures. You would never use the word corresponding within one figure. You need to compare sides or angles of two different figures. So they're in the same location but on two different figures. So the similarity ratio, we've done that before when we compare the sides, and then you can find the ratio then by taking like 10 over 5 or 5 over 10, I'm sorry, which reduces to 1/2. The perimeter ratio is the same thing. What you would do is you would find the you'd find the perimeter of each triangle. So this first triangle here, to find the perimeter, we would add up 5 times 4 times 3, and what do we get? 5, 7, 12, yeah? And then the perimeter of our other triangle, that second one there, that second triangle, the bigger one, we would add up all those sides, 10 plus 8 plus 6, and we get 18 plus 6 is 24. So to compare the perimeter ratio, all you do is take the perimeter from your one triangle and put it over the perimeter of the other triangle. So that's done right here, 12 over 24, which 12 over 24 reduces to 1/2. So the perimeter ratio would be 1/2 when we are comparing those two triangles. And then now to compare the areas, it's going to be a little bit different. We're going to find the area of triangle ABC. So remember, to find the area, quick review here, area, I'm going to put that up over here, area A equals 1/2 base times height, and the height and the base have to form a right angle so that you know which is the base and which is the height. So you have to form a right angle. So here's your base and here's your height for triangle 1. So that smaller triangle, we'll call that triangle 1, 1/2 base times height, 3 times 4. 3 times 4 is 12. So the triangle 1, the area is 12 divided by 2, which is 6. So the area would be 6. Now for the second triangle, here is that second triangle. Here's our base. Here's our base and our height. So we're going to take for the triangle 2, we're going to take 1/2. I'm really squeezing stuff in here. I should have made a bigger slide for this. 8 times 6 is 48. 48 divided by 2 is 24. So now we've got our areas as 6 and 24. I'm going to move over here for this. So 6 over 24. But we need to, so then we can actually reduce this to 1/4, divide 6 out of each, the numerator and our denominator, to get 1/4. But look here, remember the area ratio, we need to square the ratio. So we're going to take 1/6, we're going to square that. We're going to square, wait a sec here. So this is this right here, and we're not going to, hold on, we're not squaring this, is what I meant to say is, this is our ratio. If we find that the area of our smaller triangle right here had an area of 6 units, the triangle here had an area of 24. So what I did was I put over here the ratio 6 over 24. I reduced that ratio, dividing the 6 out of our numerator and our denominator to get 1/4. So that is the area ratio. What you can notice though is if we, so this is the area ratio. We notice that the area ratio 1/4 is actually, if we take the perimeter ratio, remember our perimeter ratio, we got as 1/2. If we square the perimeter ratio, it's going to give us the area ratio. So, and that goes back up to this first theorem right here that we started with, that the similarity ratio, the ratio of the perimeters is just compare the perimeter. So we compare the perimeter of the first triangle over to the second triangle. Now the ratio of the areas is if we take that perimeter and we square it. We take the perimeter ratio and we square it. Or you can just simply find the area of each of your triangles and set it up that way. Either way works. Either way works. So we've got a lot written there. I wish I had made that a little bigger. I apologize. So here we've got a problem. It says given the pentagon ABCD is similar to the pentagon FGHJK. So these two are similar. Find the perimeter of the pentagon FGHJK. So here we know the perimeter of this pentagon. So if we know that these two are similar, can we find the perimeter of this, or the perimeter of this pentagon right here? And we know this side length, and we know this side length. So is that enough to help us find the perimeter? It sure is. So how are we going to do that? Well, let's set up a ratio. Let's set up a ratio. So let's use the information that we know. We know that this corresponding side here and this corresponding side, we can use a ratio to show that those two sides are corresponding. We can set up a ratio using that information. So we would have 90 over 60. And now we know we can also set up a ratio with perimeter. So we know that the perimeter of the first polygon, which is going to always be on the top of our fraction, is 381, and we don't know the perimeter over here. We're going to say that's x. So now we've got a proportion set up, and we can use cross multiplication to solve. So let's go ahead and do that now. Let's use cross multiplication, and we'll set up the equation now. We've got 60 times 381, set that equal to 90x. So let's use the calculator. 60 times 381 gives us a large number, 22,860 equals 90x. Divide each side by 90 to solve for x. I'm going to put x equals over here because of course I'm running out of room. So 22,860 divided by 90 gives me 254, and that is going to be the perimeter. So that is the perimeter of our smaller pentagon. And look, the perimeter of our that we just found is smaller than the perimeter of our bigger one, so it makes sense. I'm going to go on the next slide, so if you need more time, go ahead and click pause to take notes. All right, so we're going to continue on with using the idea of proportions to solve problems and corresponding sides. Remember, corresponding is used when we've got two different figures. We never use corresponding within one figure. We use it to compare two different figures. So here, the problem is that we've got Jenny is 5 feet, 2 inches tall. And to find the height of a light pole, she measured her shadow right here and the pole shadow right here. What is the length of the pole? So this is our x. That's what we're trying to find. So remember, we can set up ratios with corresponding sides and then set two ratios equal to each other, and we'll have a proportion that we can solve for. So what is the first step to solving this problem, though? Look at the units of measurement. For the light post, we've got 15.5 feet. For Jenny's shadow, we've got 7 feet, 9 inches. So we've got a little bit of difference in our units of measurement. So we want to convert the units of measurement to match. So we want to, let's make it so that we're only dealing with feet. So let's change this 9 inches over here to feet so that we can have it match the length of the shadow of our light post over here where it's all in feet. So let's change everything so that it only is in feet. So we'll have to change this one as well. So let's start by converting 9 inches to feet. So how do we do that? Well, we know that in 1 foot, there's 12 inches. So we're going to take 9 and divide it by 12, and that's going to let us know how many feet are 9 inches. How many feet are 9 inches? So 9 divided by 12 gives me 0.75. So this new length is going to be 7.75 feet. That's all in the same units of measurement. We need to do the same for that 2 inches for her height. So 2 inches, there's 12 inches in 1 foot. So that means we would take 2 and divide it by 12, and that would let us know I'm going to need to round 0.17 inches, or feet, I'm sorry. 2 inches is 0.17 feet. So I'm going to rewrite that as 5.17 feet. So now I can set up a proportion. I'm going to change colors here. It's getting a little confusing to go to maybe a purple. All right, so using the corresponding sides. So this side here corresponds with this side. So I'm going to set up x over 5.17. Set that equal to our other two sets of corresponding sides, which would be 5.5 and that 7.75. So we've got 15. I meant to say 15. I said 5.5. All right. And now we're going to solve by cross multiplying. So set up our equation. What do we have? We've got 7.75x equals 15.5 times 15.17. I'm going to grab a calculator. 15.5 times 5.17. And I get 80.135 equals 7.75. X is being multiplied, so we're going to divide to solve. Again, I'm going to let my calculator do this. Divide that 80.135 divided by 7.75, and I get 10.34. So that is in feet. So that is the height of the light post. That is the height of the light post. We are done. So we use proportions to solve for that. I'm going to click pause, or not click pause. I'm going to the next slide. So if you want to click pause so that you can finish taking notes, go ahead and do that now. I'm going to go to the next slide. So that's it. So let me put up the key phrase assignment for this week. So what is the last day to submit late assignments or redos? That is your key phrase assignment for the week. You just need to answer that question. It's an important date, and I want to make sure you guys all are aware of when that last day is. So that's your key phrase assignment for the week. I've got the directions below if you need a reminder. Otherwise, remember I'm here if you guys need any help with any assignments or help with anything at all. You can always send me a quick message. You can call me, pop into a Thursday face-to-face session. And otherwise, have a wonderful rest of your week.